Okay, good. Define semantic error. A semantic error is an error in logic. An error in logic or mathematics. Since it's 2 marks, yeah. I guess that's all they could put. You wouldn't believe that in the actual answer sheet for this, they have a semantic error. It's a programming error. That is not a syntax error. They give a mark for saying that it's not a syntax error. That's crazy. Wow. I believe first of all, they give you 4 lines correctly to define a semantic error. That is, yeah. State 2 strategies for debugging codes. Well, we could state you could use a trace table, you could use a watch, and you could do a desk check. That's fine. You could do a test run for expected output. Alright, yeah. Alright, write a C function that accepts an integer array, an integer variable indicating the size of the array, and an integer variable n. The function to return a count of all the numbers in the array that are equal to n. This is a linear search. So we call it linear search one time. You could name it whatever you want. Integer array, int arr something square brackets, integer variable again in size, and then in n. And then we are going to create a variable for nothing. Count is equal to 0. And then we say for we create a c is equal to 0. For c is equal to 0, c less than size, c plus plus, right? We are going to say if arr location c is equal to n plus plus, and then just a count of all the numbers equals n, and then return count, and that's it. Yeah, that's baby food, man. Baby food. Now we reach our question. That is question is how much marks it is? 15 marks. Alright, let's get it. A theater is hosting a play. Thank you very much, theater, for hosting a play. The cost of a ticket is 200. However, if a person buys more than 4 tickets, a discount is granted. Noted. In that case, the cost is 180 per ticket. The person who buys the most tickets will receive a prize, so we need to create some variables to keep track of the person who buys the most tickets. Information related to ticket sales are stored in a file named sales.txt. Okay. Each line in the file gives the number of tickets you bought, the surname of the buyer, and the phone number, which is in the format of that. So that's a string. Alright, so this is the example. So this is number of tickets. I'll put as NT. Name will be surname. I'll put name. And this here is a number, which is a string. Right, I wouldn't put number because I'll confuse me. I'll put phone. Right, so phone is a string, name is a string, NT is a number. Right, data is terminated by -1, which appears on a line by itself. So we know that's the condition to stop our loop. And write a C program that reads sales.txt and outputs the following information to a file named results.txt. Alright, so results.txt, this is the output file, this is the input file, and we want to put the total number sold, so we need to create a variable for total, or no, they want us to put it as t. Alright, so we say t. So this is a int, this is a string, this will be char, this will be in money that should have been collected. The money should be a float, so amount, no, this should be total, so we have a float or total, and then surname and phone number of the person who sold the most tickets, so we need to keep track of that. So max name and max NT, max number of tickets. Right, if there's a tie for the most number of tickets I've sold, the prize should be awarded to the person whose name appears first, so we have to keep this into consideration. If there's a tie for the most number of tickets sold, the prize should be awarded to the person whose name appears first. How will we be able to track that, the first person? Well, as soon as we allocate a variable for first max or something, or no, we should just put it in a variable. How are we going to take that tie into consideration? Anyhow, I'll write it out and then we'll probably figure out how to do the tie after. You may assume that each surname has fewer than 50 characters. Okay, let's go. Include stdio.h, and then we have to create the main, void main, and then start. So I'll just use here to list out all the variables. All the variables that we would need. We need to create integers for number of tickets and total, nt for number of tickets, t for total, max nt, max number of tickets, and I'll just leave some space there for whatever else after that. Right, and then we have the floats, which should be total, yeah, and then we have these strings, which will be char I want to have I need to have our name. What did I put? I put S name. Name. They told us is 50, so we put the 50. And then we have to put a character for the winner name, max name. 50. Oh, I think it will work itself out, because if we check for only people who have greater than the maximum value, if somebody had the same amount, it wouldn't update because it's not greater. So that'll be cool. Alright. So those are the variables so far. Oh, I need to collect phone to phone. How much characters is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is 12. Do I have to keep track of the person's phone number too? Or it's just the phone number? I need to have the phone number. Surname and phone number. It's either take phone number, max phone. Alright, those are the variables. Now let's do the files. File star in equals f open brackets. The input file is sales.txt. Yes, sales.txt. We're opening that in read mode. Then we open the next file, out equal f open. What is the next word? The output file. Results.txt. In write mode. Okay. Alright, so let's go with the logic now. Of course, I'm setting all of these things to 0 equals 0. We initialize all of them at 0. So we open the two files. We need to get the number of tickets, which is the first number, to figure out if we're going to loop or not. So we're going to do fscanner in %d. What did I name the variable? nt, number of tickets. Right, and then we could do the while loop now to say while nt is not equal to -1. We'll read the other stuff, right? The other things on the file would be the name and the phone number. fscanf again, fscanf in %s, and we read in and the name, and then we do fscanf again in the %, and we go in with phone. Right, so we got the two things now. Now that we have the two things, we have to check now to do the number of tickets. So if number of tickets is greater than max nt, is it? That's what I name it right now. If number of tickets is greater than the maximum nt, if number of tickets is greater than max nt, I want to say that the max nt will now be equal to nt, and I have to keep track of the person who just got it, which means I have to use string copy here. So that means I have to put in string.h and copy hashtag include string.h. Right, so we put in the string.h inside there because we realized we had to use string copy because there's no way I could get the name inside the location. So I had to copy into the string that I created for the max name, which is max name, comma name. So I'm taking the name that I just got and I'm copying that into it. Cool, so now I have the max name. After getting max name, is there anything I need to do? I need to get their phone number too. String copy. I will need to take their max phone to receive the phone, right? After I receive the phone number, I believe my if statement will be good there because I've done all that they need. I've kept track of it, and only the number is greater than the maximum value will that person. And if it's the first person will be the only person there, and only somebody else after. So yeah, even if you're halfway, even if you're just more, you're okay there. Alright, so now we're doing the calculations. So we could say if nt, number of tickets, is greater than, what did they tell us to use? If number of tickets is greater than 4, yeah, it's more than 4 tickets, then it's 180. So we have to do an if to take that into consideration. So if nt is greater than 4, then we want to put the costs. Did I create a variable for cost? No, the cost had to be in the float because I'm on the value. Cost is equal to 0, right? So then we will say if that's equal to the cost is equal to 180, because that means this will more than 4. I don't need to put brackets for it. There's one thing I have to do. Because it's one thing, I don't need to put the curly brackets. I could just put it there like that. Cost equal to 180, else cost is equal to 200. Yeah. So then now I could go to say, then now I could say total is equal to total plus cost. No, can't do that. I have to multiply by the number of tickets first. So we have to figure out how much tickets are they. So total is equal to total plus cost by nt, the number of tickets. Right. What else I have to do before I end this? The number of tickets sold, which is t. I have to say t now. Number of tickets sold is equal to t plus nt. Right. And have I done everything that they asked for? I have calculated the total number of tickets. I added up the total amount of money that should be collected. I dealt with the same thing here with the alright, cool, we done. So now all I have to do is read over the number of tickets to determine if the loop continues or not. I'll take this here. So we scan the NT and then we close up the while loop. The while loop will close, and now I could print everything to the output file. So that's fprinter to the output file, and I have to print out number of tickets sold is integer, percent, and then I'll put I put the whole print or all the prints in one line. Then I'll put in total sale would be percent F, and then power comma in between just for us to make life like no, can't power comma. Oh yeah, once I put it between the quotes it should be okay. And then the winner is what's the name of the person winner? Max name. Max name will be a percent S. And then I put the winner phone will be percent S also. And now I am finished. So now I could put the variables. The variables number of tickets sold will be T. Total sales will be total. The winner would be max name, and the next one will be max phone. Right? And that's the print there that go into the output file. And before everything is done, I have to F close the files, F close the input file, F close the output file, and then we're done. Alright, 15 marks. Alright, so that's good there. Okay, any other questions? This was not difficult 15 marks. It was just a long 15 marks to make sure that you cover all of the bases, and you have to write out all the code. They usually give you a mark for not having any syntax errors, so try to make sure your semicolons in a gear. If you don't put the semicolon, it would be kind of lame for you to do all this and lose 1 mark because you miss all the semicolons that are necessary, like I did here and here and here. So yeah, keep that in mind. Okay, number 6 now. For each of the following function calls to print month, state whether it's a lexically or syntactically correct or both. Give one reason for your answer. Alright, this one, is it lexically correct? Yes. Why? Because I don't know, because it contains a data type, name, or no, return type, name, and data type for the argument. Yeah. Now we have to say whether it's syntactically correct. Wait, this is weird. Okay, let's just say both. I'll just put both. Yeah, I guess that's what we're looking for, because it's syntactically correct and it's lexically correct. Print month void int num. This is lexically it is correct. Yes, because all the words are acceptable. Syntactically no, because void is in the wrong. Yeah. So lexically means that it will not give you a warning and say, well, illegal expression used, because void is a legal expression. But syntactically it will say nah, something wrong. Expected something here, so that would be a syntax. But yes, I know what you're thinking. This is a weird question. That's a weird question. All the best. Identify the part of the program translation process that eliminates repeated operations and recognizes parts of the program so that it can be executed faster and more efficiently. Give that away as code optimization. Right. Recognizes parts of the program, code optimization. Alright, distinguish between a compiler and an interpreter in terms of translation and execution. Oh my goodness. Look at words. I don't know which one I do. Words or code, imagine how you feel. Alright, so formats. Compiler checks the entire program and reports errors in interpreter, check line by line, and report errors as they are found. Cool. Compiler saves time because all errors can be compiled, collected at 1, and debug. Interpreter takes longer because each error has to be dealt with before you can move on. Right, that's that. State 1's difference between structures and arrays. Oh, that's easy. Arrays can only store the same data type, while structures can store multiple data types. Cool. Write a C function, calculate VAT that accepts two values of type float, price, and VAT, and the program applies VAT to the price and returns the new price. Note VAT is given as a percentage. VAT is given as a percentage. What do they mean by that? If VAT is given as a percentage, oh, that means it'll be like a whole number. Right? Float, find the VAT would be the data type. I mean, it would be the return type, and we get a price, float price, and float. I don't know, I'll just call it VAT value. VAT value is equal to price multiplied by given as a percentage, so 1 plus VAT divided by 100. Yeah, so you multiply by, so like if it's 2% VAT, you get 2, then you get 1.02 multiplied by price, and then you return the VAT value. Right? You return VAT value. That math's not confusing to anybody, right? Yeah. So that's all that. I mean, you could break it down into pieces if you feel like it, but you know. Oh, this question. They make a big mistake with this question. Yeah, the actual answer sheet says, due to an error in the question, flexibility will be allowed in the answer. That's literally on the CX answer. So, if I could explain this the best way possible. What they tried to do was to do a string compare function. String compare is supposed to check the two strings to see if they are the same, and if they are the same, they'll give you a result of 1 or 0, right? That's literally what string compare is supposed to do. So we're supposed to get two strings, and then the funny thing is that they use string length inside the string compare function when string compare is, so they're basically trying to create a new string compare. Why? I don't know. Right, so we have these lengths, and we calculate the length of string A and we calculate the length of string B, and store them in length 1 and length 2, right? And if the length of the first string and the length of the second string are different, then you take the length of the second one and put it in a variable called len, and you put it in like that. Means you keep the length of the bigger one. Why? I don't know. So while I is less than the length of the bigger one, you are going to do something, which is check to see if I is less than length 1 and I is less than length 2. But for I to be less than length 1 and less than length 2, the I here would be set to 0 at the start. So I think they make the mistake here by this I here wasn't supposed to be set to 0 at the start, because this I will always be less than length 1 or length 2 no matter what happens, because the I will be set to 0 all the time. So if it's true that it's less than that, then you have the if A location I is greater than B location 1. So string A, if the first letter in string A is greater than the first letter in string B, no, the second letter in string B, return -1. Why return -1? Because the first letter, the letter at location 0 is different from the letter at location 1. Else, if a letter at location 0 is less than the letter at location 0, return 1. And this is where it starts to get confusing and complicated. I don't know if when all they read this, all they was like, nah, this ain't making any sense. Anybody made sense of this so far up to the point that I reached? Like when you were doing the question, or you just watch it and was like, yeah, I'll take a L on this one.
Yeah, I definitely.
Good thing is it was only 3 marks. So yeah, right. So as I was saying, yeah. Right, so as I was saying, what happens next? Right, so then the else now, this else will never get to run because this, sorry, no, the else would get to run if the 0 is greater than length 2, but the 0 will, I, which is 0, will never be greater than length 2 because the value of I never changes anywhere in this program. So setting I to 0 we'll call that one. So this else wouldn't matter. So what they want us to do is lay out what happened in line 15 to 20. So what we're trying to do is explain these lines here. So we're going to say if right, so yeah, that 15 to 20, right? So 15 to 20, we could describe it because we could understand by saying if the letter located at index I is bigger than, sorry, at A index I, at word A index I is bigger than the letter located at word B index 1, then you would return -1. Else C letter word A index I is less than word B index I, and return 1. Right? So that's basically describing this portion right here. You could describe that. That's not that hard to describe. It's basically using the terminology of arrays. So letter, index, anytime you use words like index or whatnot, yeah, it'd be good there. Alright, then part G now is to check line 23 to 28. So we could describe this by saying the same thing, same concept. If index I is greater than the length of B, so if index I is greater than the length of word B, then return -1. Otherwise, if it is greater, if index I is greater than word A, which is this, then return 1, I'll return 0. Right. They're explaining that there, and now this is where they basically, you have to kind of either infer what they're trying to do or not infer what they're trying to do. So what they're trying to do is check the strings to see if this word is the same as that word, or if it's bigger or smaller. So if you get dog and goat, what will happen is that based on the inference, this is the only option that will get done all the time, because 0 will always be less than the length, or if the 0 is not less than, so you're only gonna get either 1 or -1 being returned. So 1 or -1 will happen. So your answers will be 1 or -1 all the time. So basically, if you have 1 or -1 for any of these, there would be no problem. So we're checking to see if A location I is greater than B location 1. So A location 0, which is the D, is this greater than B location 1? Is D greater than O? Meaning, is D a bigger number than O? No, because O comes after, so D is actually in here. D is less than G, because G will be a bigger number. I mean, O, sorry. O, that's how you're comparing to. You're really comparing the B location 0, because this I will be 0 all the time, and this B will be 1. So you compare the first letter or the second letter. So if it is, what we comparing if D is greater than O. Is D greater than O? The answer is no. So you will get -1, because you'll get the return -1. Yeah, return -1. No, you'll get 1. Yeah, the answer is no, so you'll get 1. My bad. Yeah, so you're supposed to get 1. Cool. That's the first one. Second one is, right. So now we're comparing the next one, D and A. As we're comparing, is D greater than A? The answer is no, so we're supposed to get -1. And then this one, we comparing the D and the O. Is D greater than 0? I mean than O, sorry. Nope, we're supposed to get 1. And then this one here, we comparing the D to be greater than O again. So we're supposed to get 1 again. Alright, that should be it. Alright, everybody understands why the last question is a problem. Well, why it was wrong, because really and truly it was supposed to compare the first location with the first location and then keep looping over and over and over. So really and truly it's supposed to check the D and the G, and if it's not correct, then it will give you a -1. But if you have dog and dog, it's supposed to be right. We got the D, then we got the O, then we got the G. That's what the while loop is for. The while loop was supposed to check to make sure that as long as I is less than the length, and I would have increment somewhere, but the I never increment anywhere, because I'd have to go for the length of the word. Yeah. So once you answer this, so this is a prime case of, even if you don't understand the question, answer, because it could get your marks even if they make a mistake. Good.